Alright guys, so transforming parent functions. These are 1.3 notes day 2. What's going to happen here guys is for the first 3 I'm going to show one method of doing this, and then for the second 3 I'm going to show another method of doing this. So taking a look at number 1 here, before I would even start to try to fill out any of this information, I would try to graph it first. Okay, so the way to identify what kind of graph this is to look at the equation. Okay, and then as we're looking at it, we're kind of looking at what's around this x, and as you can see, around this x we have a squared. So because there's a squared around the x, that means it's talking about a quadratic function. So then our quadratic is y equals x squared. So then what I recommend is to build the most basic function first, and then with that function, we're going to do all of the transformations of our graph. Okay, so we have, if you don't remember, we have x and y, right? We build the table. So when we plug in 0, we get 0. When we plug in 1, we would get 1. When we plug in -1, we also get 1. When you plug in 2, you get 4. And then when you plug in -2, you still get 4. Okay, so then graphing that basic function, 0, 0, 1, 1, -1, 1, +2, +4, it's here, -2, -4. So now we have the basic function graphed. Now we do all of those transformations to it. So remember, our first transformation always has to be the a value. In this case, the a value is 1/2. So then with the a value, what's going to happen is we're going to take all the y values and we're just going to multiply them by 1/2. And that'll tell us all of these new points. Okay, so we multiply all those by 1/2. We get 0, 1/2, 1/2, 2, and 2. So then we're going to go 0, 1/2, 1/2, 2, and 2. I just realized I did not put those on 4. That's 4. Okay, so now we've shrunk our graph. Now we do the shift, right? This is telling us to go h is 1. Let's make it a different color. H is 1, k is -1, so that's to the right 1 and down 1. So then we literally just take all of these points and move them to the right 1 and then down 1, right 1, down 1, right 1, down 1, right 1, down 1, to the right 1, and down 1. So then our final graph is this quadratic right here. Okay, so it should look nice and pretty. Awesome. So now we can write the domain, range, y-intercept, and end behavior here. So our domain is going to be, in this case, all real numbers because we can pick whatever x. Our range, as you can see, is now -1. So then we're going from -1 to +infinity. Y-intercept, so we actually have the point of our y-intercept graph, which makes that nice. So it would be 0, comma, -1/2. And then our end behavior here, so end behavior statement is as x goes to, and then we're going to say +infinity, f of x is going to +infinity. And then as x goes to -infinity, our f of x is going to +infinity. Okay, so that would be our end behavior statement. If for some reason we did not get the y-intercept, the way to find the y-intercept is to plug in 0 for x. So f of 0 is equal to 1/2, 0 minus 1 squared, minus 1. Do this math, we have 1/2 times 1 minus 1, so that's 1/2 minus 1, which is -1/2. Okay, so say we weren't given the y-intercept, we just plug in 0, and that'll give us the y-intercept. Okay, so that's the first one. Let's take a look at this next one. Again, to identify what parent function to use, we look around the x. So we have a square root here. So that means our parent function is going to be y equals the square root of x. If you recall yesterday, we were only really plugging in 3 points into this, 0, 1, and 4. That gave us out 0, 1, and 2. So we go 0, 1, 1, 4, and then 2. 1, 2, 3, yep. 4 and 2. Now we do our transformations. Transformations in this one are a is negative 1, which is our flip, and then we have an h value of 1, a k value of 4, so that's to the right 1 and up 4. So flip tells us we just multiply all of these by negative 1. So 0 stays on 0, 1 becomes negative 1, 2 becomes negative 2. And then finally, the shift is going to be to the right 1, up 4. So then we go to the right 1, up 4, right 1, up 4, right 1, up 4. And then we can draw our graph, right? There's not going to be any negatives to the square root, so then it's just going to be going like this. Well, that was poor. Like this. A little bit better, still kind of poor. And now we can write the domain, range, and y-intercept and all those things. So, in this case, our domain, as you can see, we're starting at 1. Okay, so then it's going to be from 1 to infinity. Our range in this case, so now we need to think, what's the lowest value that this is going to be? So it's coming from negative infinity, and then it's going all the way up to this value right here, which is 1, 2, 3, that's 4, right? And it's included. So then we put a 4 there. Y-intercept. Okay, if we look at this, this is never going to cross the y-axis. So in this case, there is no y-intercept, so not applicable. And now we can write our end behavior statement. So as x goes to infinity, our f of x is going towards negative infinity. And then as x goes towards negative infinity, or to the left, right, f of x is going to what value? It's going to this value right here, because that's the left end of the graph. So it's going to 4. Okay? And so that's how we would graph number 2. All right, number 3. Number 3. So look around our x. Looks like it's absolute value. So then we have y is equal to the absolute value of x. So then our points here, right, x and y, 0, 0. 1, 1, negative 1, 1. That's about all you need for the absolute value. So 0, 0, 1, 1, negative 1, positive 1. And then this is telling us that our a value is negative 2. So a is negative 2, h is negative 2, and then k is positive 3. So a value means we're just taking all these y values and multiplying them by the a value. So let's do that. So times negative 2, times negative 2, times negative 2 gives us 0, negative 2, negative 2. So 0, negative 2, and negative 2. And then we're shifting to the left 2, up 3. So then I'm going to do that. Each of these goes to the left 2, up 3. Left 2, up 3. Left 2, up 3. Okay. And now we can graph it. We've done all the transformations, so then we graph. Should look something like this. Okay, that would be our absolute value graph. So our domain, all real numbers here. Our range, as you can see, we have a maximum value, 1, 2, 3. So maximum value of 3. So it's going from negative infinity all the way up to the value 3. Y-intercept in this one, okay? So as we look at our graph, if we graphed it really well, we can see that it goes through negative 1. If we didn't graph it really well, remember, the way to find the y-intercept is to just plug in 0 for x. So if we did f of 0, we would get negative 2 times 0 plus 2 plus 3, which that's negative 2 times the absolute value of 2 plus 3. So that's negative 4 plus 3, which is then negative 1. Right, so our y-intercept is 0, negative 1. And then we can write our end behavior statement. So as x goes to positive infinity, or as we go to the right on this graph, our f of x is going towards negative infinity. And then as x goes towards negative infinity, f of x is also going towards negative infinity, right? Because as we go to the left, it's going down. Okay? So that's one method you can use. Draw in the parent function, and then do all of the transformations to it. So literally just like we did our transformation day. Okay? For the next three, I'm going to show a different method of how to do these questions. And it's okay if one of these methods clicks with you and the other doesn't. By all means, pick the one that works best for you. So, again, we look around the x for our parent function. It's squared, so that means our parent function is y equals x squared. If you're still struggling with this, start with a table, okay? But hopefully we're getting to the point that we are starting to learn this. So, the different method actually does what I told you guys not to do, which is kind of funny. But you can do it this way, which some people actually like this way. So the h value in this case is -2. The k value is -3. So the first thing we're going to do is shift it. And what we're shifting is the origin of this graph. So we're shifting the origin, whatever the shift is telling us to move it. So it says in this case -2 and -3. So we're going to move it -2 and then -1, 2, 3. Okay, so our origin is here. So what I like to do when I do the origin shift method, I build a new x and y. So this is my new y-axis, so y prime. This is my new x-axis, so x prime. From here, now I'm going to graph the parent function. So the parent function is the x squared graph. So 0, 0 is my first point. 1, 1, -1, 1, +2, +4. -2, -2, +4. Okay, so that would be my parent function. And then we already did the shift, so we're not worried about it. The only thing we have left is our flip. So we're going to take all of those values, we're going to multiply them by 3/2, right? So 0 is going to stay at 0. 1 times 3/2 is going to become 1.5. 1 times 3/2 is going to become 1.5. 4 times 3/2 is going to become 6. So 1, 2, 3, 4, 5, 6. And then again, 4 times 3/2 is going to become 6. So then when we draw this graph, should look like our quadratic, but we just stretched it out just a little bit. Not a lot, because 3/2 is not that much bigger than 1. But we did stretch it a little bit. Okay, so that's the second method. Shift the origin and then graph the parent function. For our domain is all real numbers for any x squared graph. The range, so the range here, -3 is the lowest it goes, so -3 to +infinity. Again, we graphed the y-intercept, so 1, 2, 3, so it's going to be 0, 3. And then our end behavior, as x goes towards +infinity, f of x is going towards +infinity. And then as x is going towards -infinity, f of x is going towards -infinity. Okay? So let's take a look at the next one. Next one, if we're looking around our x, we have a cube, so that's our cubic function, so y equals x cubed. So then if we build that xy table, 0 we get 0, 1 we get 1, -1, now we get -1 with the cubed function. 2 we get 8, -2 we get -8. Okay, so if we're doing the same method we did in 4, we're going to start with the shift. Shift is h is equal to -1, k is equal to +1, so we're shifting to the left 1 and up 1, so left 1, up 1 would put us here. This is our new origin. Okay, so then we treat this like it's the origin of the original graph, so y prime, x prime, because those are a new origin for us. And now we can graph the function, right? The function is the x cubed function. So it goes 0, 0, 1, 1, -1, -1, +2, +8. So 1, 2, 3, 4, 5, 6, 7, 8. So -2, -8. 1, 2, 3, 4, 5, 6, 7, -8. And then we already did the shifts, so now the last thing we need to do is just divide everything by 1/4. Okay, so 0 would stay at 0. 1, which is right here, would become 1/4. 8 would then become 2. Okay, 1 right here would become 1/4. -8 would then become -2. Okay, and notice I'm doing everything from this new x-axis and y-axis that I built. I literally am disregarding the original ones. I don't care about it anymore. Okay. Once we do that, we graph this equation. So it's going to look something like this. Okay. And then that's how we would graph that. Domain, all real numbers for any x cubed function. Range, all real numbers for any x cubed function. Y-intercept, so we did graph it again. So now we're looking at our original origin to figure out the y-intercept. So it's up 1 1/4. Okay, so that is 5/4. So 0, 5/4, right? Because 1 plus 1/4 would be 4/4 plus 1/4, 5/4. Again, if you don't know that point exactly, just plug in 0, right? 1/4, 0 plus 1 cubed plus 1. That's 1/4 times 1 plus 1, so that's 1/4 plus 1, 5/4 again. Okay, so always, 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 when in doubt with your y-intercept, plug in 0 for x. And behavior, as x goes towards infinity, f of x is going up, so it's going towards infinity. As x goes towards negative infinity, f of x is going towards negative infinity. Okay, so hopefully you're starting to get a handle on all of those characteristics. All right, last one. Last one. So, near our x, cube root function. So then y equals the cube root of x. Okay, so if you don't remember these, it's 0, 0, and then we need to pick perfect cubes. So 1 is a perfect cube, -1 is a perfect cube, 8 is our next perfect cube, would give us out 2, -8 would give us out -2. Okay, we're going to do it the second method again, so we're going to shift first. So our shift is h is equal to -2, k is equal to -1, so we're shifting, h is not -2, h is +2, right? That's a +2. So then we're shifting right 2 down 1, so right 2 down 1, this is our new origin, y prime, x prime. So now all of our graphing is happening from here. So we draw this parent function, right? Parent function 0, 0, 1, 1, -1, -1, -8, 1, 2, 3, 4, 5, 6, 7, 8, -2, +8, or +8, 1, 2, 3, 4, 5, 6, 7, 8. And then +2, right? So that's going to be up there. And then from here, so we've done the shift, now we just need to do this. So that's saying our a value is -3. So our a value, we just multiply all of the y's by -3. The reason we multiply all these y's, guys, is because that's our vertical shift, right? So then it stays 0, becomes -3, +3, -6, +6. So then we come here, we say -2 is becoming +6. So we go 0, 1, 2, 3, 4, 5, 6. -1 is becoming +3, so 1, 2, 3. +1 becomes -3, so 1, 2, 3. And then +2 becomes -6, so 1, 2, 3, 4, 5, 6. So then when we're graphing this, going to look kind of crazy. 0 stays at 0, sorry. It's going to come down like this. Okay. All right. So that is graphing that cube root function. Domain, all real numbers. Range, all real numbers. Y-intercept, as you can see here, right? We didn't graph the y-intercept perfectly, so we're going to have to plug it in. -3, cube root of 0 minus 2 minus 1. So that's -3 times the cube root of -2 minus 1. Cube root of -2, that's some random decimal. It's bigger than 1, but smaller than 2, so it's like -3 times -1 point something. Okay, I don't have my calculator on me to do that. And then minus 1, so that's going to be +3 minus 1, so it's going to be a little bit more than 2. Looks like in our drawing, yeah, look, it's just above 2 and under 3. So I have no idea. I'm just going to guess that it's like 2.9 or something like that. So 0, 2.9. If you have a calculator, you can get the more exact answer and let me know how close I am. Anyway, end behavior. So as x goes towards positive infinity, f of x is going towards negative infinity, right? Because it's going down. And then as x is going towards negative infinity, so to the left, f of x is going towards positive infinity. Okay? So that's all of our graphing, right? 4, 5, and 6 we graph differently from 1, 2, and 3. So you guys can really pick which method you like more. Do you like draw the parent function and then do all the transformations? Or do you like shift to the origin and then do the a-value transformation? Okay? Either way is great. They both give you the correct answer. So just pick whichever method you like best. Okay? If you have any questions, always reach out to me, Canvas or email. I always will respond to you guys. And make sure you try the homework and come with questions tomorrow. Have a great rest of your day.